Hi guys, this is experimental chemistry and we are looking at apparatus commonly found in a chemistry lab and their uses. Thermometers commonly used in chemistry labs are liquid and glass thermometers. The liquid inside may be either an alcohol or mercury, which is the liquid metal. And the measurements that we can see are of the least count of 1 degree Celsius. So normally thermometers have a least count of 1 degree Celsius and the values are recorded accurately to 1 decimal place. That is true for all temperature readings. All temperature readings must be recorded to 1 decimal place. So, if the least count is 1 degree Celsius, then the error in measuring a single reading would be 0.5 degrees Celsius. So the error in measuring temperature value using a thermometer depends on what is being measured. If we are going to measure the temperature of a solution, then that would be called a single measurement. So the error for that measurement would be 0.5 degrees Celsius. So single temperature reading would have an error of 0.5 degrees Celsius. This is true for measuring the temperature of a liquid or even measuring the room temperature because lab thermometers always measure the room temperature. If we just look at the temperature that is there on the thermometer, that temperature would be the room temperature. So the error in that reading would be 0.5. However, if we are performing an experiment and we need to measure delta T, now, what is delta T? Delta T is the difference between the initial and final readings. So, there are two types of experiments that use temperature readings. One is an exothermic reaction. So, in an exothermic reaction, the temperature increases. So, what we do is we measure the initial temperature and then we measure the final temperature. But in order to calculate the difference in temperature, we subtract the initial temperature from the final temperature. And this gives us the difference in temperature. So, in such calculations, the error would be 0.5 into 2 because we have read the temperature twice. So the error in this reading would be 1.0 degrees Celsius. Similarly, in an experiment that is endothermic in nature, an endothermic experiment is an experiment in which the temperature falls. And in this case, the initial temperature is higher than the final temperature. So, in order to measure the delta T, we subtract the final temperature from the initial temperature. So that would give us the difference in temperature between the two readings before and after the experiment, which is equal to delta T. And in this case as well, the error in reading the thermometer would be 0.5 times 2 because the thermometer was read twice, giving an error of 1.0 degrees Celsius. So in order to calculate the percentage error in measurements of delta T, the percentage error would be equal to 1.0 upon whatever the difference in temperature is, as in whatever delta T is into 100. So this would be the formula used to calculate the percentage error in measuring the difference in temperature. The formula for measuring the error in a single reading of the thermometer would be, just to measure the error, 0.5 upon temperature into 100. This would give the error of a single reading of the thermometer, which would usually be the error in measuring the temperature of a liquid or the room temperature. And this is how a lab thermometer is used to measure different temperatures. A stopwatch or a stop clock is a piece of lab apparatus used to measure time, especially during rate of reaction experiments. So, when we use a digital stopwatch, the time that we can see as stated in the readout is 7 minutes, 53 seconds, and 26 microseconds. So, we need to remember that time is recorded to the nearest second, which means that time would always be recorded in whole numbers. So the reading on the digital stopwatch says 7 minutes, 53 seconds, and 26 uh, microseconds. So this would be 7 minutes and 53 seconds. We will disregard the 26 microseconds. If the microseconds goes above 50, then we would round up 53 to 54 seconds. So that is how time is recorded using a digital stopwatch. If we are going to use an analog stop clock, so the bigger hands are for seconds, this one, and the smaller time measurement inside of the stop clock is for minutes. So if the seconds hand takes a complete 360-degree rotation, then the minute hand would move to 1 minute. And that is how time is measured using a stop clock. So right now, the minute hand is at 60, which means 0 minutes. Because if it was more than 0, then the hand would have moved, the minute hand would have moved. And the second hand recording the seconds to the nearest second in whole numbers would be 50, 51, 52, and 53. So this reading is at 53 seconds. And this is how we use a stopwatch or a stop clock to measure time during chemistry experiments.